For today's lesson, we are going to continue on trigonometric identities. In particular, today we're going to focus on how to use trigonometric identities in proving that something is true. So the first thing you see here is just the exact identities that we learned last time. They're grouped together, the quotient identities, the reciprocal identities, the Pythagorean identities. And so this is nothing new. You learned these last time. But what we're going to do this time that is new is we are going to be using these identities not just to simplify something, whether it's an expression that you just want to simplify down to one trig function if possible, and it's not just used so that you can, say, find the sine of x if you know what cosecant of x is. But we are actually going to be using them in proofs. So what that means is you're going to have some sort of a statement, and what you're going to do is you're going to either prove or verify them. And generally, the best way to go about showing that a statement is true using these trig identities is to start with one side and use identities to change it until it looks like the right-hand side. So the one thing we're not going to do is we are not going to do the same thing to both sides. We don't want to change both sides. We want to keep one side the same and take the other side and continue to apply identities to it until it looks like the other side. Now here I wrote down, start with the left-hand side and change it until it looks like the right-hand side. You can start with the right-hand side and change it to look like the left-hand side. That's fine too. Generally, I would say to pick whichever side looks more complicated and try to start with that side and then simplify it until it looks like the other side. Generally, it's easier to simplify down something than try to complicate something until it looks exactly like the other side. So for all of these examples, we're going to pick a side to start with, and then once we've picked that side, we'll apply identities. So that's why I put the identities there for you on the notes, and apply them until we're able to simplify it to look like the other side. Here's the first example. It says verify that 1 plus sine of x minus sine squared of x all over cosine of x is equal to cosine of x plus tangent of x. So again, you pick one side to start with. You are not doing the same thing to both sides. Pick a side to start with, simplify it until it looks like the other side. So in this case, it looks like the left-hand side is more complicated than the right-hand side. So I'm going to start with the left-hand side, and I'm going to see if I'm going to be able to simplify this down. You want to look out for anything that you can group together that can simplify. You want to see if there's anything that you can split apart to simplify it down until you get to the right-hand side. The nice thing about this is that you do know what you want to get at the end, right? So unlike a lot of math problems where you're trying to get to the answer, you don't know whether or not your answer is right or not. With proofs, it's nice because you know what you're trying to prove. You know you're trying to show this is equal to cosine of x plus tangent of x. It's just a matter of getting there. Okay, so the first thing I would say that I see here that might be useful is I see a sine squared and I see a 1 in there. So what I'm going to do is I'm going to put those two together right next to each other. And then that way, the 1 minus sine squared, we can actually simplify just the part that's in parentheses. So remember, 1 is equal to sine squared plus cosine squared. Okay, so sine squared plus cosine squared minus sine squared. Okay, so now you can see the sine squared and the minus sine squared will cancel. That leaves us with cosine squared plus sine all over cosine. Okay, so remember what we're trying to get at. We're trying to get that this is equal to cosine of x plus tangent of x. So we're actually pretty close. We see that in the numerator we have two terms. So perhaps if we were to split this apart and very clearly get two terms and not just two terms in the numerator, but if we were to divide both of these by cosine, right, we can split it up that way. Okay, and then let's see, cosine squared over cosine is equal to cosine. Okay, that's good. That's the first term we have. And then the second part, sine over cosine is equal to tangent, right? That's the quotient identity. So that is equal to tangent of x, and now you can see that at the end, we've gotten the right-hand side. So notice that in this example, we did nothing with the right-hand side. We just knew that was what we needed to get at the very end. We started with the left-hand side. We saw things we could rearrange, regroup. We used a Pythagorean identity. We split up the fraction. We divided both of those by cosine. We used the quotient identity. And at the end, we were able to get the right-hand side. So it's nice knowing that you were able to get what you wanted to at the end. And you should be pretty confident that all the steps that you did to get you there, you were able to use identities, you were able to regroup things, use your algebraic knowledge to help you get to that other side. Okay, let's do another example. Secant of x times parentheses secant of x minus cosine of x is equal to tangent squared. Okay, so again here it looks like the left-hand side is more complicated, so we'll start with that. So let's start by multiplying that out. So we'll go ahead and distribute the secant. So now we have secant squared minus secant times cosine. Okay, now at this point, again, some of this just takes practice, trying to see a couple steps ahead and see what would be helpful now. Remember that what we're trying to get at. We're trying to get tangent squared at the end. Now currently we have secant squared in there, so that's pretty close to getting us to the tangent squared. All we need is a 1 somewhere in there. Now remember, secant and cosine, those are reciprocals of each other. So if we were to replace secant with 1 over cosine here, then the cosines will end up canceling each other out. Now of course here, if you wanted to, you could change cosine to 1 over secant. You'll end up with the same thing. You'll end up with 1 because the secants will cancel out. So now we have secant squared minus 1. And what do you know? Secant squared minus 1 by a Pythagorean identity is equal to tan squared. All right, let's take a look at example 3. Prove that sine of x minus sine of x times cosine squared x is equal to sine cubed x. Okay, so again, pick the side that looks more complex, in this case the left-hand side, and we want to make that left-hand side equal sine cubed. Okay, start with the left-hand side, and let's see if there's anything we can do here. Okay, so we have everything is in terms of sine and cosine. So eventually we want everything just in terms of sine, right? Because at the end on the right-hand side, it was just sine cubed. Okay, well, first thing we could do is we could factor out a sine of x from both of those terms, leaving us with a 1 minus cosine squared in parentheses. And now we just need to make this 1 minus cosine squared somehow equal, what do we need? We need 2 more signs, right? Sine squared. Okay, so using a Pythagorean identity, we can replace the 1 with sine squared plus cosine squared. Again, it looks a little bit more complicated at first, but the cosine squareds, you'll see, will cancel. So cosine squared and the minus cosine squared cancel. That leaves us with sine of x times sine squared. And if we're multiplying sine by sine squared, now we have 3 of them, so this is equal to sine cubed. All right, last example. Prove that tangent of x times sine of x plus cosine of x is equal to secant of x. Okay, so let's start with that left-hand side. Clearly the right-hand side is very simple. And one strategy that I haven't really talked a lot about yet, but it is a good strategy. So if we're not sure what to do, change everything into just in terms of sine and cosine. That way you only have 2 trig functions that you're dealing with, which means you're more likely to be able to combine things. You're more likely to be able to get terms that are raised to a power, which will look more simplified. And that way, that might be a way to help you simplify it down a bit more. So if you're really stuck, you're not sure, if you can plug something in that will help like cancel something out or simplify something, just try getting everything in terms of just sine and cosine. What's nice is that actually everything can be written in terms of just sine and cosine. Why? Because, well, tangent is sine over cosine. Cotangent's the reciprocal of that, so that's cosine over sine. And then secant and cosecant are just reciprocals of sine and cosine. So it's very, very easy to write everything in terms of sine and cosine. So in this case, the only thing that's not in terms of sine and cosine is the tangent, which I just mentioned is equal to sine over cosine by the quotient identity. Okay, again, it might look more complicated at first. That's okay. So let's go ahead and multiply that. So now we have sine squared over cosine. Okay, now remember at the very end, the right-hand side, it was just secant of x. It was just one term. So we're definitely going to need to add these two together. Because we're adding two things together and one's a fraction, we need a common denominator. So that means in the second term, to get a common denominator, we have to multiply that second term by cosine over cosine. So we have sine squared over cosine plus cosine squared over cosine. Now we have a common denominator. Now we can add the two fractions together. So now we have sine squared plus cosine squared all over cosine. And then sine squared plus cosine squared is equal to what? It's equal to 1, right? Because that is a Pythagorean identity. And we're almost there. 1 over cosine. Well, cosine is the reciprocal of what? The reciprocal of secant. So 1 over cosine is equal to secant of x by a reciprocal identity. So your answer is secant of x, which is in fact the right-hand side. So again, with all these proofs, they're different from just trying to simplify an expression. What's nice about proofs is that you have some statement that's given to you with an equal sign. You want to be able to show that one side is equal to the other side. Pick the more complicated side. Simplify it down using identities, using knowledge from algebra and what you can do with certain things, how you can combine certain things, factor certain things. Use all of that to simplify it down until you get to the other side. And again, what's nice about proofs is that you know for sure that you've been able to prove it because you were able to use some identity, some algebraic knowledge in order to get to the other side. And if you're able to get to the other side, you know you've been able to do it correctly.